Assalamualaikum and hi everyone, this is Dr. Shazira. In this video, we are going to be discussing the Thomas algorithm method. But before that, we need to know the specific criteria for the Thomas algorithm method. Okay, for a system AX equals B, okay, in order for us to use the Thomas algorithm method, the matrix A must be a tridiagonal matrix. Okay, so this is what it means by the tridiagonal matrix. Okay, so you have non-zero elements at the main diagonal. Okay, the D elements here, and then you have non-zero elements at the lower diagonals, denoted as C's here, C2, C3 up to the Cn, and we also have non-zero elements at the upper diagonal, denoted as E1, E2 up to the En. Okay, other than the three diagonals here, all of the elements in the matrix A are 0. So you can see at the lower part and the upper part here, they are all 0. So that is the tridiagonal matrix. Okay, so in terms of notation, we use the D, okay, for the main diagonal. So we start with the D1 because we have D from, start with row number 1. Okay, so that's why the notation is D sub 1. Okay, the same thing for the E, at the upper diagonal, the notation is E. So you can see the subscript start with the 1, okay, because E, we have E at the first row. Okay, but for the C, the notation starts at the subscript 2 because the C start at row number 2. Okay, so we have C2, C3 up to the Cn. That's in terms of notation, we have C, D, and E. All right, so that is the specific criteria that need to be fulfilled, okay, before we can proceed with the Thomas algorithm method. Okay, so it depends on the problem. Sometimes initially A that is given to us is not in the form of tridiagonal yet. Okay, but maybe after some rearrangement, okay, in terms of swapping the rows here and there, you can come out, okay, with a in the form of tridiagonal matrix. But if it is still not possible, okay, after you try to rearrange your matrix A, you still didn't get the A which is in the form of tridiagonal matrix, then it means that you cannot proceed with the Thomas algorithm method. So you need to choose any other method that you have learned before. Okay, so that is the specific criteria for the Thomas algorithm method. All right, so what do we have? Okay, in the Thomas algorithm, so basically we have these 7 formula, okay, correspond to the algorithm. Okay, so we have alpha 1 equals D1, so on and so forth until the X here. Okay, so the 7 formula here, normally given in the exam. Okay, but what I want to highlight here is basically the first 3 formula here is actually comes from our normal step in the LU method, which is A equals LU. Okay, so for any other method, okay, that you have learned before this, you have 3 steps, okay, in solving the LU. Okay, so the first one is A equals LU, where you are supposed to get your matrix L and matrix U. And then for equation number 4 and 5 here, it is actually comes from step number 2, which is Ly equals B, okay, in your normal LU step. Okay, and the last 2 basically, okay, from Ux equals Y. So the Thomas algorithm basically can still comply to the 3 normal procedure in solving, the linear system using the LU method. Okay, so A equals LU, Ly equals B, and Ux equals Y. It's just that, we transform, okay, all the process that we have before, okay, in LU method into algorithm. Okay, so that when it comes to computer program, okay, when you want to solve the system, large system basically, okay, using the Thomas algorithm, so it is easier for us, okay, if we can write the programming code based on the algorithm that we have here, the 7 algorithm here. But for the purpose of exam, okay, or test, normally the system that will be given to you normally around up to 4 by 4 only, I think, okay, not more than that, okay, because we can understand the process basically, okay, will consume more time if you have a large system. All right, so we will see one example. How can we use all of this algorithm here, all of this formula here, to come out with the solution, okay, of a system of linear equation. Alright, consider this example. You have 4 by 4 system here. So first thing first is to check whether your A is tridiagonal or not. Okay, so initially if we take out our A, then we have 0, 0, 3, 4, 2, 9, 1, 0, 0, 1, 9, and 4, and then 2, 1, 0, 0. Okay, so clearly this is not a tridiagonal matrix, okay, because if we, mark the main diagonal here, and this is the upper diagonal, and this is the lower diagonal, okay, so other than the 3 diagonals, all the elements are supposed to be 0, okay, but you can see we have 3, 4, 0 somewhere here, and here we have 0, 2, and 1. So initially this is not a tridiagonal matrix. Alright, so initially A is not a tridiagonal. So what do we need to do? We need to rearrange A. Okay, it means that you need to try to swap rows, okay, so that you can come out with tridiagonal matrix. Okay, so maybe you want to write down, okay, your tridiagonal matrix for 4 by 4 system. Okay, so in general we have non-zero element over there. Sorry, something like that. Okay, and at the second row we have non-zero element here, here. Okay, and then we have 0, non-zero element. Okay, so basically that would be our tridiagonal matrix for 4 by 4 system. Okay, so our new A then, so rearrange, swap the rows. Okay, so the aim, maybe you can see, what is the equation that have 2 zeros at the end. So okay, correspond to this. Okay, so the first row should be 2, 1, 0, 0. Okay, and the second row, you can see you are looking for equation that have only 1 of 0, okay, at the last column. Okay, so correspond to this one. Okay, so it means you are going to have 2, 9, 1, 0. And then at the third row, you are looking for, the first element should be 0. So we have 0, 1, 9, and 4. And lastly, we have 0, 0, 3, and 4. Okay, so that is our new A. But don't forget, okay, every time you change your A, do not forget that B must follows. Okay, so change B accordingly, okay, because it comes with the A. Alright, so 2, 1, 0, 0. So 9, and then you have 6, 8, and 8. Okay, so that is your new A and B. Okay, so now we have a tridiagonal matrix of A here. Okay, so we are good to go with the Thomas algorithm method. Okay, so normally I would suggest to the student to have a table, okay, so that you can see clearly what are the formula and what are the columns that you need to have, okay, in the table. So it is easier for you to do the calculation later. So form the table. Alright, so this is the algorithm, okay, in the table form. Okay, so you write down the formula at the left side here, and then you have 4 columns correspond to your dimension of your system. Okay, so we have 4 by 4 system here. So we have column for I equals 1, I equals 2, I equals 3, and I equals 4. Alright, so now let us see what can we put at the first place. Okay, so at the first place, we always can fill in D, E, C, and B. Alright, so what is D? Remember, D is the main diagonal element. Okay, so this is D. Alright, and at the upper diagonal, we denote as E. And at the lower diagonal, our notation is C. Okay, so we put accordingly. So now D, so D1 is A11. So we have 2, okay, and then D2 is A22. So 9, 9, and 4. Okay, so E is the upper diagonal. Okay, also start with the E1. So we have 1, 1, and 4, but we don't have the E4. Okay, because the elements of the E here only up to the 3rd row. Okay, we don't have E at the 4th row, right? And then the C, so C is the lower diagonal here. Somehow it starts at row number 2. So it means we don't have C1. So it starts with the row number 2. So we have 2, 1, and 3. And then for the B, B is the elements of the vector B. Okay, so we have 9, 6, 8, and 8. Alright, so those are the 4 rows that we can fill in, okay, at the first place. Now, the calculation starts here with the alpha here. So you have 2 formula for the alpha, alpha 1 and alpha I. Okay, so at this column, this is for the alpha 1. Okay, so specific for alpha 1, it is equal to the D1. So our D1 is 2 here, so we put straight away this is 2. But for the alpha 2 here, so this column here is for the alpha 2, it should follow this formula. So alpha 2 equals to the D2 minus C2 beta I minus 1, which is beta 1. Alright? So if I can write the formula, okay, maybe somewhere here. So alpha 2 here is equal to the D2 minus C2 beta 1. So you can see we have D2. So this one, no problem. We have the D. We have the C2 somehow. Okay. But we don't have the beta 1 yet. Where is beta? Beta is at the next row. So beta should be here. Beta 1 is here. So it means that before you can proceed, okay, before you can calculate the alpha 2 here, you need to calculate the beta 1 first. So what is beta 1? Beta 1 is the E1, okay, over alpha 1. We have E1 here is 1, and then we have alpha 1, which is 2. So somewhere here, this is 1 over 2. Okay, in terms of decimals, it is 0.5. Okay, so we can calculate B first. So it means that in terms of flow, after you get your alpha 1, you need to go down first to get your beta 1. After that, only then you can get your alpha 2. Because in order for you to calculate the alpha 2, you need the information of beta 1. Okay, after that, you can substitute here. D2 is 9 minus C2. C2 is 2 here. And then beta 1 is this value, 0.5. Okay, so plus minus here and there, you are supposed to get your alpha 2 is 8 somehow. Okay, so in the exam, you can, straight away use your calculator. You don't need to write, the formula in the table here. Okay, so straight away write it. Okay, and similarly, if you want to find the alpha 3 at the third column here, you see in terms of formula, it is D3 minus C3, but somehow for the beta here, you need beta 2. So beta 2 is somewhere here. Okay, so it means that before you can get the alpha 3, you need to go down first to get the beta 2. So what is beta 2? Beta 2 is E2 over alpha 2. E2 is 1. Yeah, this is E2. Alpha 2 is 8. Okay, so 1 over 8. And then we have, in terms of decimals, it is 0.125. Okay, with that value, only then we can proceed with the calculation of alpha 3. Because now, alpha 3 would be D3 minus C3 beta 2, okay, which can be computed now, okay, because we have all the values of D, C, and beta, okay. So for this one, we are supposed to get 8.875. Okay, so similarly, now we already know the pattern, so we should go down first to get our beta 3, which is E3. Okay, E3 is 4 over alpha 3, this one. Okay, so 4 over 8.875 here, so we are supposed to get 0.4507. Okay, with that value, okay, we can go up to get our alpha 4, which is D4 minus C4 beta 3, right? So this is 2.6479. Okay, and then after that, we don't need to go down, because you will go down if you want to get the alpha 5, okay, which is not the case here. Okay, but if you have a larger system, then you may need to have alpha 5. It means that you need to go down to get the beta 4. Okay, but for this example, okay, enough up to this. Okay, so it means that you can just put dash over there. Okay, so we are settled on alpha and beta. Now the W. Okay, so we have two formula for the W. W1 follows this specific formula. Other than that, it follows this formula. Okay, so W1 is B1 over alpha 1. I'm sorry, here this is not alpha I. This is supposed to be alpha 1. Okay, sorry about that. So W1 is B1 over alpha 1. B1 is 9 here. Okay, alpha 1 is 2. So 9 over 2, so 4.5. Okay, and now W2, W3, and W4 should follow this formula. So if I can write, W2 here is equal to the B2 minus C2 W2 minus 1, so W1, okay, over alpha 2. All of them are known values, so no problem. So we have the B2, which is 6 here, and then C2 is 2, W1, okay, the value that we have just computed earlier, and then D2 is 9. Okay, so we can plug in the formula, the value easily. So that is supposed to be negative 0.375. Okay, so similarly for W3, okay, so we have B3 minus C3 W2 over alpha 3. So all of them are known value, so it should be no problem. Okay, but just be careful when you pick up the values from the table. So this is 1.9521. All right. Next, okay, we have this is the last row. Okay, our x value. This is our intention at the first place. Okay. In your general formula, you have xn here. Xn equals wn. N is the dimension of your matrix. Okay, so for this problem, we have 4 by 4 system. So it means our n is 4. So I put here x4 equals w4. Okay, and this is specific for the x4 only. Okay, other than that, we should follow this formula. Okay, so for this row here, we need to start from the back, at the back. Okay, so it starts with the x4 equals w4. So we get the value of x4 first. Since it is equal to w4, we just copy the value from the previous row. Okay, because this is w4. Okay, only then we can compute the x3. Okay, so the flow is like that. You can get the x3, and then after that you get the x2, and lastly you get the x1. Okay, because you can see, in order for you to get the x1, so x1 is actually w1 minus beta 1 x2. So you need the information of x2, which is here. So the same thing, in order for you to get the x2 here, somehow in the formula, you need the information of the x3. Okay, when you want to get the x3, you need the information of x4, which is known actually. Okay, so that's why we start from the back. Okay, we start from x4. Okay, and then follows accordingly. Okay, so x3, okay, x3 equals w3. So we have w3 here, so this is our w3, minus beta 3, so this is beta 3, x4, so this is x4. Okay, so plug in. So we have 0.0639 here. Okay. Okay, so for the x2 here, the formula is w2. Okay, so w2 minus beta 2. So this is beta 2 times x3. So we put the x3 here. All right, so we have negative 0.3830. And for the x1, you're supposed to get 4.6915. Alright, so that's it. Okay, that's how you use the Thomas algorithm. Okay, it's basically just some method of calculation. Okay, so the formula is given to you. All of the 7 formula here, the 7 formula here will be given to you, but somehow you need to know how it works. You need to understand the flow, what do you need to find first in order for you to get the alpha here, okay, so on and so forth. Okay, but other than that, it's just plug in the correct values into the formula. Okay, so it should be fine, I think. Okay, so at the end, you don't have to write down one more time what is x1, x2, x3 here, because it is understood from the table here. At the last row, it is understood that this is the value of x1, x2, x3, and x4 respectively. Okay, so I think that's all for the Thomas algorithm. We can recall a bit. First of all, you need to make sure it is a tridiagonal matrix. Okay, tridiagonal matrix. Try to rearrange if it is not tridiagonal initially. Okay, and after that, you can proceed with the algorithm and do the calculation carefully. Okay, plug in the values correctly. Alright, so that's all for the Thomas algorithm. Bye bye, and thank you so much.